Lecture 6.9, a deeper look at virtual images. Consider the following images. What you're seeing here is that there are 4 images. There's one, two, 3, and 4. All of these are virtual images. And in this case, we're looking at virtual images. Let's say that they're from lenses. Okay, so we assume these are all virtual images of a lens. From a ray diagram, of both lens, we have 2 possibilities. We could have a converging lens or a diverging lens. So let's go look at that. So I'm going to say that I have, in this situation, I'll call this a converging lens. It doesn't really matter the order. So let me draw this. So if I look at this here, and then I'll copy this, and then over here, I'll have a second lens that's diverging. So when I'm looking at this, the only way we can have an image that's diverging, that's virtual, I'm going to say that this object here is going to be inside the focal point. So let's say that in this case, we're going to call that the focal point. And now I'm going to go in and I'm going to draw my object, let's say. So if my object is, let's say, right here, and then I have my focal point right here, then my first ray is then going to go parallel and then through the focal point. But we know that because this is going to be virtual, we have to follow the rays backwards because it's inside the focal point. And then my second ray has to go through the center of the lens, which goes like this, but then I follow it back like this. So then I see that I have an image. This image here is definitely larger than the object. It's erect, right? So if I look at this, I have an erect image. It's larger and it's virtual because it's behind the lens. For a diverging lens, we only care about the focal point back here. So then if I again put my object right here, then again I go through my rays. I gotta take my ray number 1, and then it diverges as if it's coming off from the focal point. And then I take my second ray, again, it goes through the middle of the lens, and you can see here that I have an image that's, again, a rect, but this time it's smaller. So I have an erect, smaller image, and therefore it's virtual since it's erect. So what we're seeing here is, using these ray diagrams, we could tell, right? So from the ray diagrams, one concludes that when you look off to the side, that is the actual object. So therefore, lens one, you could see the original object, right? Here's the object. And of course, the image is where the lens is, and you can see that it's larger. So it must be coming from a converging lens. Why? Because it didn't change the orientation. It's larger, and it has to be that way. On the other hand, when I look at the second one, here is my image. And you could see that the image is smaller than the object. So this guy has to be a diverging lens that's producing that image. Again, if you look at this guy here, here's the image again, and you can clearly see that the numbers are smaller. So therefore, when I look at 3, this is also a diverging lens. But when you look at 4, note it doesn't change the orientation of the eye, but it clearly makes it larger. So therefore, we conclude, when I look at that image right there, that it's definitely a converging lens. Now, one image that we have not talked about is virtual images in plane mirrors. Here, what we find here is that if I have an object in front of a mirror, let's say that this is my object, and then here is a mirror, where this is the back side, a virtual image will be produced at the same distance behind the mirror that it is in front of the mirror. In other words, if I look at this object image distance, it's the exact same thing as the object. Light in a room. Suppose we have a room with perfect mirrored walls. So if I sketch this out, mirrors are that silvery perfect white. So then that means here that I'm going to have so now if I have my light bulb, I'm going to shine light from this light bulb, and it's going to light up the room. So instead of drawing this complicated picture, I'm going to simplify this picture for right now, and I'm just going to say that I have a rectangular box like this. And what I do know is that I have this silver mirror all the way around. And then this light bulb is going to light up the whole room. And that's what I'm using the yellow for. So then I'm going to imagine that this is my light bulb. And this light bulb now is just putting out light like this. So again, this right here, assuming that this is the backing of the mirror, the surface is a perfect reflector. Since there is a continuous emission of light from the bulb, the room grows brighter and brighter. Furthermore, if there was an external light switch and you turned it off, the room would stay lit. However, everyday experience tells us this is not the case. So the question is why? Let's change scenario and think of your bedroom. With no mirrored walls. What happens to the brightness in the room? Well, experience tells us that the light in the room does not get more intense and stays at a constant brightness. Question is, why? In equilibrium state has been established. And what I mean by that is that the amount of light emitted by a light bulb has to equal the amount of light being reflected off its walls, absorbed, and escaping out the room. So here was a great question from my daughter. So my brilliant young daughter, Olivia, asked this beautiful question when I was putting her to sleep. And here was her question. Daddy, where does the light go when the lights are turned off? My answer was, it's still in the room, sweetie. It's still in the room. When light is absorbed after the lights are turned off, the absorbed light gets re-emitted back into the room at lower energies, frequencies, that means it turns into IR, microwaves, radio waves, etc. Which we cannot see. So continuing along the same storyline, maybe I should say, let's change our storyline and again start with a room with no mirrors and a single light bulb. So picture-wise, what am I actually seeing here? So here's the room. And this here is just, right, it's just a wall, a standard drywall. And what I'm going to do here is that I'm going to have a light bulb right here. So when I look at this light bulb, what's it doing here is that it is emitting light. And as it emits light, we know that light is going everywhere. Now, what we're going to do here is that we're going to measure this light. So what do I mean by that? Right here in this corner, I'm going to have a light sensor. Okay, there's my light sensor. So this measures light intensity. And right now, it's emitting an intensity, which I'll call I1. Here, we clearly see that this is a wall. And so what you're seeing here is that when equilibrium is established, the brightness in the room is constant. So what does that mean? So what that means here is that I'm going to have light that's doing what? I'm going to have light that's coming in, and this light here, we're going to say this is absorbed light. And then some of the light from the walls is reflected back. So this is reflected light. So because there's constant emission of light, what we're going to see here is that we have less reflection and we have more absorption. So because this is the case here, we then say here is that there's going to be less light is in the room. Now what I want to do here is that I want to add a mirror wall. So now, if a mirror wall is installed on the right wall or the right side, what happens to the brightness in the room? So if I take my situation again, what I'll do here is that I'm going to copy this image and I'm going to redraw it. Now modify it to fix what I needed to do to be. So again, here's my light source. Okay, so what I'm going to do here is that I got to get rid of this wall right here. So what's happening now is that I'm going to put a mirror. So I have a mirrored wall right here. And then, of course, we have our backing that doesn't allow any light to escape. So this is telling me here that this right here is a mirrored wall. So what happens here? So I want to be careful here. So what you're going to see here is that the light bulb has an intensity of I1. Now, instead of light being absorbed by that wall, light is now going to be reflected instead. So that means I have no absorption, but I have reflection. And what I'm going to do here is that I'm going to say that this reflected light now increases the total intensity in the room. So in this situation, so instead of absorption, so now a new equilibrium is established. And so what you're seeing here is that now I have more reflection, and now I have less absorption. So when I start to analyze the intensity in the room, because I have less absorption and more reflection, I'm going to have more light is in the room, which then tells you that it's brighter. So then that means here is that this measures a higher light intensity. Now, most people would say that because, there's less absorption and there's more light being reflected, that's the reason for the bright room, the brighter room. Well, although this answer is correct, my brilliant young daughter, Olivia, stated something different but also correct. She said this: Daddy, I know why the room is brighter. There are 2 light bulbs in the room, as she pointed to the virtual image of the bulb in the mirror. And she was correct. And so this is really where I wanted to get to this discussion, to talk about more details about virtual images. So let's go back and analyze this. Okay, let's go back and analyze this. So now let's call this situation 1. And what we're going to do here is that we're going to measure the intensity with no mirrored wall. So let's look at this thing. So let's say that this is my wall. Let's make it 3 squares. And what I'm going to do here is that I'm going to put in a light bulb right here. Right, so, and then what I'm going to do here is that this light bulb is emitting light. So if I'm in this room, we want to measure the intensity of the light bulb. So once again, this right here is the wall. Remember, no mirrors. So now if I have my light sensor right here, right? Here's my light sensor. This light source emits an intensity of I1. And when I say I1, that means it measures I1 at the light sensor. Because remember, the brightness at the surface of the bulb is different than the brightness when we get to the actual light sensor. So as a consequence, if there's no mirrored wall, then we have what? We have that we have less reflection, more absorption, which tells us then that we have less light in the room. And this is what we define as the intensity 1. Now let's go to situation 2. So what I'm going to do here is that I'm going to copy this. And you know what? I'm going to run out of space. So I'm going to move this wall over a little bit because I'm going to need that extra space. So now what I'm going to do is that I'm going to copy this guy and I'm going to bring it down with me. So now here we go. So now what we're going to do is that we're going to measure the intensity with a mirrored wall in the room. So if I now put this in here, so what I'm going to do different here is that I got to take this wall out. And so what I will have is that I'm going to have a mirror right here. So as we said before, what's going to happen here is that the light is now being reflected off the mirror. And so what we're seeing here is that in this situation, what we're going to find here is that there's more reflection less absorption. So therefore, I'm going to have more light in the room. So the question is, how much more light? Well, again, I have my light sensor right here, but now there are two sources of light. There's the intensity due to I1, but now I also have this new light source, I2, and this is the contribution of light reflected by the mirror. So again, I didn't really say this before, but this is my mirrored wall. So at the light sensor, that means this intensity now, it now measures I1 plus I2. So you see that there is more light in the room because there are two sources that are contributing here. Now, let's look at a third situation. And this is really getting to my daughter's explanation. So you got to remember that what I'm going to do here is that I'm going to change it, and then I'm going to come back to the mirrored virtual image of the light bulb. So now what I'm going to do here is that I'm going to measure the intensity with a second light bulb farther behind the missing wall with the same intensity I1. So what do I mean by that? So let's draw a picture again. So starting from my other picture, here's what I'm going to do. So now I don't have a wall here. Okay, I don't have a wall here. But this is where the wall was. Now, what I want you to pay attention to is that if you're looking at a plane mirror image, it looks something like this. I have an object. And let's say this is the mirror right here. Right, here's my plane mirror. So the distance that this object is in front of the mirror is also the distance behind the mirror. So when I look at S prime, it's equal to S. So it's the same distance. So now what I'm going to do here is I'm going to take this light bulb right here and I'm going to put it. So if this guy's 1, 2, 3 squares, then I have to put this at 3 squares behind. Now remember, it starts off with intensity I1. So now here's my light sensor. And the only thing we care about is what is the intensity of the light at the light sensor, not where it starts at. So what you're seeing here is that now light is coming from the light sensor. Excuse me, from the farther away light bulb. But when it gets to the light sensor, that has a lower intensity. Okay? So once again, right here, we have no wall here anymore. And what we're saying here is that this light bulb, this is located at the virtual image distance of a plane mirror. And this guy right here, this is a real light bulb with intensity I1, but it's farther from the light sensor. So what you're seeing here is that now the total intensity at light sensor is then going to be I1 plus I2. So what I'm saying here is that in this situation, one cannot tell the difference between situation 2, that is the mirrored wall, and situation 3, which is a second, I should say, a real second light bulb in the room. they both read the same intensity. That is crazy. That is a really, really crazy statement. So if I try to bring this all together, this is what my daughter stated without knowing what a virtual image was. Simply by looking into the mirror, she did not recognize the mirror reflecting light, but saw its virtual image and called it a real light source, even though it's not. In other words, the key point is this. One cannot tell the difference between a virtual light bulb versus a real one. So if I think about this picture here, here's what I imagine here. So here's where the wall was at. And now I need to put my light bulb right here. So when I'm looking at my light bulb and it's emitting light, if we have, oops, let me try this again. There's no wall. And so what I'm going to do here is that I'm going to take this guy and I'm going to copy it. And I'm going to put it right over here. And so what I'm going to see here is that in this situation, there's no wall. This is light bulb number one, right? This is, oops, try that again. This is light bulb number one, and this is light bulb number two. So when I'm looking at the light coming from this source here, I'm going to come in and I'm going to try this in a different color here. Let me get something lighter. So I'm going to say that if I look at the light coming here, and the light coming there, and the light coming here. So I would say that in this situation, this guy is a real light bulb. So if I'm standing right here, what do I actually see? So now let me copy this and do the exact same thing. Okay, so now I'm right here, but now the difference that I'm going to do is that this guy right here, this guy is really a virtual light bulb. It's not a real light bulb. Ah, I should have just drawn it from the beginning. Okay. Right, so this is a virtual light bulb because now what I have here is that I have a mirror. So if I have a mirror here, so I'm going to say that now I have a mirror at this spot. So when I'm looking at this thing here, here's what I'm going to find. I look at this and it looks, so if I follow this back, it looks like my eye is telling me that this is where the light is coming in. And so this guy here is a virtual light bulb. And so if I now make a blocker, now imagine that I have a blocker now. Okay. And let's say that I can't tell whether I'm talking about the situation of a real light bulb or a virtual one. So now if I copy this and let's say that I move this here. So if I block this guy right here, or if I block, you know what? I know what that's not what I do here. Let me try this again. What I really want to do is that I want to make it nice and big so that it blocks everything out. So if I come over here, let me, so this is what I'm saying. So now, let's say that I can block everything. So now if I copy this guy, and now if I paste it and I do this, and then I take this guy and I move this guy over here, I can't tell the difference between each of these situations. In other words, one cannot tell the difference between, I already stated that. One cannot tell a difference between a virtual light bulb and a real light bulb emitting the same light. Something to think about.